Now I want to talk about interpreting radian measure. If the angle is in degrees or radians as a fraction of pi, determining which number is the angle is fairly easy. You can just kind of look at it and see. But what if we're using radians in decimal form? And in the same way, what if you have a trig value like square root of 3 over 2 or 1/2, and you see that ratio and you recognize, oh, that's a trig value. But what if we put the trig value in decimal form? It becomes less easy to recognize which one is the angle and which one is the trig value. So in these three problems 1 through 3, I've done a calculation on my calculator. And for example, sine of 5.7 is negative 0.5507. And in all of these three calculations, one with sine, one with cosine, and one with tangent, one of these is the angle and one of them is the trig value. Now, how do you know which one is which if they're both in decimal form? So here's what you need to remember. That's when we have a regular trig function, the input is the angle and the output is the trig value. When we have an inverse function, the input is the input is the trig value and the output is the angle. So you recognize which is the angle by whether it's a regular function or an inverse function. So when we look at the first problem, this is not an inverse function. That means the input is the angle and the output is the trig value. Number 2 is an inverse function. We see the little -1 superscript here, which indicates an inverse function. So this is an inverse function, which means we're inputting the trig value and we're outputting the angle. Now we can tell to some extent for sine and cosine because we know that the trig value for sine and cosine has to be between -1 and 1. So that gives us a clue that the trig value is often a smaller number, although we could have a radian angle that's less than 1 also. So that's not always the best way to tell. But when we get to tangent, erase my little stray mark there, when we get to tangent, a tangent trig value can be any number, all real numbers. So it's going to be a lot harder to tell with tangent. So for tangent, now this is not an inverse again. So that means this is the angle input and the trig value output. Alright, so let's take a look now at what I want you to do with these problems. These are not calculation problems, these are concept questions. I'm asking you to demonstrate by illustrating what these two numbers mean. So I want you to start out by drawing where the angle is. So 5.7 radians, we need to think about every radian angle cuts one radius length. So one radian angle here would cut a radius length of 1 radian. Or would cut one radius length, so that would be 1 radian angle would be about right there. 2 radian angles would end up right about here. 3 here, 4, 5, and 6. So 5.7 radians is about right here. So the first thing I want you to do is label the angle. Secondly, I want you to label the trig value. Well, the trig value is a ratio of two sides of a right triangle, the reference triangle that goes with the reference angle. Since we're talking about sine, we're talking about opposite over hypotenuse. If I only have a single number, I can always write it as a ratio by just writing it as a number divided by 1. So we could say the opposite side is negative 0.5507 and the hypotenuse is 1. So I'm going to draw my reference triangle and label the appropriate sides. So this side right here is negative 0.5507, which makes sense because it is going in the negative direction. The hypotenuse is 1. And when we look at the triangle with the angle we drew, we should see that the hypotenuse is only about half as big as, the opposite side is only about half as big as the hypotenuse. So it should make sense with the numbers that were given. In the second example, the angle is 1.2239. Well, we know 1 radian is about right here and 2 is about right here, so where does 1.22 end up? Just to double check, I'm going to look at pi over 2. Pi over 2 is 3.14 divided by 2, which is approximately 1.57. So that tells me straight up at 90 degrees is about 1.57 radians. So 1.22 radians is probably about right here. It's a little more than 1 radian, but not all the way up to 90 degrees. And if I draw my reference angle and my triangle, it's going to look like this. So I'm going to have to label my angle kind of outside here since it's not going to fit inside the triangle. So this is 1.2239 radians. And then I need to label the two sides. The trig value here is adjacent over hypotenuse for cosine, and that's 0.34 over 1. So the adjacent side, this little tiny side here, is the 0.34, and the hypotenuse is 1. Notice that the hypotenuse is the radius of the circle, and this 0.34 looks like it's about a third of that radius, so that looks really reasonable. The third one, the tangent one, uses a negative angle. So instead of counting positive radius lengths around the circle to figure out where those radian angles are, we would have to count negative in the negative direction, just like we do with angles in degrees. So this would be -1 radians and -2 radians. Actually, -1 is probably not quite that high. -1 radian, -2, -3, and what I want is -2.35. So that would be about right here. So -2.35, and I'm going to draw and label that -2.3561 radians. Okay. Now I need the trig value. Well, the trig value for tangent is opposite over adjacent, so that's going to be 1.0002 divided by 1. That's pretty close to 1 over 1, which would indicate a 45-degree angle. So this is nearly a 45-degree angle, very, very close. So I'm going to be labeling the opposite side and the adjacent side. Notice that in both of these in quadrant 3 would be negative. So a negative divided by a negative gives me a positive, but both of these sides individually are negative. So what I'm asking you to do on this problem is to identify clearly what the meaning of the numbers are by drawing a reasonably accurate sketch of the angle and labeling two sides of the reference triangle. Now problem number 4 is a concept question, but I'm asking you, why is this not possible? So in this case, this would be, since this is an inverse function, this is the trig value, and this is the angle in radians. Most of you probably are recognizing that the trig value is not correct because for inverse sine, the domain is -1 to 1. So -4 is not in the domain. For inverse sine. So the question is, why is -1 to 1 the domain? Why does -4 not work? So what I'd like you to be able to explain to me is that -4 over 1 would have to be opposite over hypotenuse. And if I tried to draw a triangle for that, I would be in quadrant 4 for an inverse tangent. So this would be -4 and this would be 1. Okay, so this is not possible because the opposite side can't be bigger than the hypotenuse. Longer than the hypotenuse.